My name is Dan Gordon. The name of the paper is WebPerf, Evaluating What-If Scenarios for Cloud-Hosted Web Applications. Authors are Young Jiang, Lenin Ravindranath, Suman Nath, and Ramesh Govindan. The main focus of the paper is cloud latency, so that's where we will start. What is cloud latency? The paper's focus, like I said, is cloud latency and the effective way to minimize it. In simple terms, cloud latency is the time a user request spends in the cloud. As a developer developing cloud applications, they need to minimize this as cost effectively as possible. Like any project, be it in the cloud or not, obviously cost efficacy is very important. So part of cloud latency is due to the network not be optimized by the developer. An example of this would be a geographical limitation. For instance, if the front end is in California and the back end is in New Jersey, nothing a developer is going to do is going to make the latency of that any better. But choosing an appropriate cloud configuration is the key for the developer to minimize overall cloud latency. So they do have quite a bit of control. So what's the problem when it comes to minimizing cloud latency? So there's many different pricing tiers and configurations offered to developers by the PaaS, or Platform as a Service cloud providers. Just to give you an example, just for web servers on Microsoft Azure, so 10 tiers. Think about all the different options from all the different providers. I mean, it's too much to count, too much to list the different possibilities. But you have endless possibilities, which is good, but obviously it complicates things. Also, large discrepancies in prices and performances in different tiers complicates further. Some companies, for instance, use multiple different tiers of cloud resources. Name a few examples. Netflix, Alibaba, and Airbnb use 6 different storage components as of the writing of the article. Flexibility is great, like I said, but it does make it finding the most cost-effective packages a bit of a challenge. So what are some options in determining what makes the most sense to minimize cloud latency? One possibility offered in the paper that doesn't make a ton of sense, as they elaborate on, is to deploy each configuration and then measure cloud latency. But obviously, this is incredibly expensive because you would have to buy the tiers, and incredibly slow because you would actually have to build for each tier and then deploy it, and it's just insanely expensive and insanely slow. Another option is to take a look at the SLAs, or the service level agreements from the cloud providers, but not only are they overly complicated, they're hard to look at for pure quantitative analysis, as they're quite wordy, and like I said, there's not a real mathematical attitude to them, so it does make it a little bit hard to analyze purely quantitatively. Another option is for the developer just to look at data. Besides the fact that data might not be available, even if it is, it's quite a bit slow and it can be very expensive as well. So even with reliable data, it still may not accurately reflect the end-to-end latency, as there's other factors that can happen. So one option put forth is WebPerf. And what WebPerf is, it's a tool that estimates the distribution of cloud-side latency in different what-if scenarios. And just an aside, the technical term for a what-if scenario is just a request under hypothetical change. The way WebPerf works, it works by combining offline latency models of various cloud APIs with application logic of various compute and input-output calls. So it allows the developer to quickly determine the most cost-effective tier to use. And it's designed to fulfill 3 basic requirements. First, more obviously, is to estimate cloud latency distribution of a given request and a what-if scenario accurately. Number 2, it must do so quickly. And 3, it must require minimal developer input. So how it works? So as a prediction algorithm that uses causal dependencies between multiple computation and input-output calls. So it evaluates what-if scenarios in a 3-step process. It builds latency profiles of various APIs offline. It computes dependency graphs of a given request, and then it predicts cloud latency by a combination of baseline latencies, which are known, with the above and for various hypothetical situations. And these hypothetical situations take in the following inputs, which are various API profiles, which again are known, dependency graphs and baseline latency of tasks, and a what-if scenario. And a what-if scenario is literally just an example that they provided was a resource X is deployed at location Y. So cloud latency depends on the following. Causal order in which computation and input-output calls happen, and then the latency of each computation and input-output call. And the above is relatively stable and predictable, so only 10% of the requests were non-deterministic in the experimental testing, so not 90% they were able to accurately and mathematically predict what would happen. API latency is application independent. So the performance of individual input-output calls can be mathematically modeled independent of the business logic and independent of what's actually going on in the application. And this does allow reproducible statistical models of offline APIs. So importance and relevance of the issues. Obviously, cost efficacy is perhaps the most important issue in business, and that's any business. Sometimes as a developer, we don't see it, we more hear about it, but of course, we're delivering a product, and the goal of a product almost entirely is to make money. So you want the service or application to work, but you don't want it to overextend the budget. So finding a reliable, quantifiable, and repeatable way to measure and compare different cloud tiers is essential. On top of that, providers are constantly changing tiers and costs, making repeatability essential. So being able to keep customer satisfaction is based on the product and overall cost, which is the essential issue at hand WebPerf is trying to solve. If you didn't care about money, you would just buy the highest tiers. If you didn't care about satisfaction, you would just buy the lowest tiers. So WebPerf is basically trying to find that equilibrium point, trying to find that middle ground. What makes the most sense for our product? The results. How did WebPerf do? And again, this is according to the paper. I will go into some issues I may take with the results a little bit later on. But anyway, the error of the prediction is less than 7%. They claim that the end-to-end prediction is slightly more accurate than just their cloud-side prediction. And they use what's called workload hints from developers to increase WebPerf's predictions. They didn't really expound too much on what a workload hint is. Just literally one line in the paper that says workload hints. It seems to be just basically a guidance the developer gave them on how to structure their algorithms. But more about that later. So the estimated median error for the prediction algorithm is 0.3%, which is excellent. And then some actual errors on terms of the actual queries for applications. So for join queries on SQL tables with greater than 10,000 rows, without the workload hints, WebPerf's prediction median error was 28.9%. With the workload hints, it was 4.6%. On Azure CDN's data access, the median prediction error was 40% without workload hints, and again 3.2% with workload hints. So obviously, we are starting to see a little bit of a pattern here. For social forum sharding table storage, the error was 90.1% with workload hints, 5.9% with workload hints. So these are the parts that use the workload hints. Basically, see the algorithm is not really functioning as it's supposed to without these workload hints. And if you go back a couple slides, one of the goals is to use minimal developer input. But again, more into that later. I'll continue for Contesto ads. So what they did was they downgraded to a basic tier, which recommended having guidelines of 30 concurrent connections. When they stayed within the recommendation, WebPerf's median error was 2.1%. When they went over, they used 50 concurrent connections. Their median error was 87.3%. Basically meaning that it's more predictable when they stay in the guidelines. Once they exceed the guidelines, it's less predictable what's going to happen, which obviously makes sense. Using 9 different API calls for social forum website, the relative errors were as follows: 1.8, 1.68, 10.1, 5.55, 2.8, 2.12, 6.68, 2.4, and 18.4. The paper claims that WebPerf can be highly accurate even for websites with complex dependencies. So issues with experimental data. I had quite a few issues with it. Primarily, they only tested it with six scenarios. To me, anything with any sort of scientific or mathematical background, they'd have to do a heck of a lot more testing than that. Again, I don't have a number, but I was thinking the hundreds, if not thousands. Obviously, that would take some time. But if they're trying to prove a point, 6 is just ludicrous to try to prove their point with. The math they used to create the algorithm was quite sophisticated. The functions they used, the function calls, but seemed almost lazy on the testing side. Is obviously something some developers can can relate to. Spend all the time coding. Sometimes testing isn't the most fun part. But again, to only test 6 almost defeats the purpose of having such an algorithm. Another issue is that it was only used with Microsoft Azure, which is better because you have the same control group. You're not going to AWS, would complicate, like I said, the control group. But with such a small subset of data, it doesn't really have any bearing on how it would work with other cloud providers. And I feel workflow hints are just the cop out to compromise the data. They literally claim that they don't, that one of their goals is to have minimal developer input. So using workflow hints almost defeats the purpose. It's almost writing an algorithm that you know the answer to. It's almost defeats the whole purpose of it. They didn't explain why or how they did that exactly. So I think absolutely they identified a real issue. Finding a cost-effective way of programming to the cloud and working within the guidelines of the platform as a service providers is absolutely important. I just don't think they offered a real solution. My overall opinion, was laid out a great structure. They laid out a real issue, like I said, about choosing the appropriate cloud computing tier for developers. But they claim to have found a solution that requires developer input. So not only does that go against one of their stated goals, it makes it less portable and less reproducible. So to me, even if they tested this on a thousand different applications, if they only tested on Microsoft Azure, it wouldn't have any use to someone using Amazon service. However, the paper was well written. It was straightforward, had an abstract, introduction, overview, went into technical detail, summarized results, and conclusion. In terms of its form, it was absolutely straightforward. Like I said, I just don't think they proved the points. I think the numbers before the workflow hints showed that the algorithms maybe weren't as effective as they hoped. The workflow hints allowed them to cater what they needed to do to fit. And then they claimed it a success. Thank you for listening to my presentation. All the images were taken from unsplash.com. I didn't use any sources other than the paper provided above. The paper was funded by Microsoft Research. It was tested using Microsoft Azure, not the most desirable situation. I attempted to find out if WebPerf is still around just to see how they did, just from my own curiosity. All I was able to find was the current GitHub repo. So in terms of whether it's actually used, utilized, or success, or if my feelings about it are correct, I really couldn't find too much information on it. But again, thank you for your time.